Hey everyone, we're going to evaluate the integral over the interval 0 to 2 of this function and using substitutions and basically inverse trig functions. So if you look at this, you have this x squared plus 4. So this one has the form of here. So we're going to use substitution, allowing x to equal 2 tan of theta. And the reason we're using 2 because 2 squared is 4. So you always want to let your a be the square root of whatever's here. So therefore, if x equals 2 tan of theta, then dx is going to be 2 secant squared theta dx. Also, let's go ahead and substitute our numbers. So x is 0 when theta is 0, and x equals 2 when theta equals pi divided by 2, or pi divided by 4. So now we can integrate this and change our integral from 0 to pi over 4. And my x cubed, just cube this. So that's going to be 2 cubed tan cubed of theta. And then we have this square root part. Now the square root part, again, we've gone over it in several other videos, but that's just going to be, if you put it in the, I'm just looking at this part. So square root of x squared plus 4. So that's going to be 4 tan squared of theta, and then you have your add your plus 4. So when you take that out, you're going to factor out the 4. You get tan squared of theta plus 1. So that's, you take out the square root of 4 is 2, and this equals secant squared of theta. And so this is just going to be 2 secant theta. You don't need the absolute value because we're in, this should be negative, quadrants 1 and 4, and cosine is positive in quadrant 1 and 4. Therefore, secant is also positive there. So now that we did that part, we can substitute the square root of x squared plus 4 is 2 times secant of theta, and then our dx is here. So that's going to be times 2 secant squared theta d theta. All right. Now, simplifying this further, you're going to get, let's count this out. We have how many 2's? We have 3 here, 1 here, and 1 here. So that's 2 to the 5th. Let's pull that out. And we're going to have pi over 4 to 0. We're going to go ahead and keep everything straight, but I'm going to pull out another tan. So I'm going to write this as tan squared theta. Then we have our secant squared theta. And then we have another secant theta tan theta d theta. So all I did was take this and expand it. All right. Now we know that, before I move on to the next slide, that tan squared theta is really secant squared theta minus 1. So what I'm going to do is I'm going to let u equal secant theta. So therefore du equals secant theta tan theta d theta. All right. And before, let's write out what we had. We had 32, and then so pi divided by 4 to 0. We had secant squared theta minus 1, secant squared theta, and then we had secant theta tan theta d theta. So there's your du part. So now we're using u substitution. So we're going to write, you can write this as 2 to the 5th if you want. And also when you do your u, you're going to have to change these again. So secant of 0 is just going to be 1. And secant of pi divided by 4 is square root of 2. So we have to change that. And now we can use u substitution. So this is going to be u squared minus 1 times u squared. And this part here is just du. Simplifying further, you're going to have, let's go ahead and write it as 32 now. 1 to square root of 2. This is u to the 4th minus u squared du. So now all we have to do is integrate this. So we've got 32, that's 2 to the 5th. And it's going to be 1/5 u to the 5th minus 1/3 u cubed. And we're going from over the interval 1 to square root of 2. So let's plug all that in. You get 32 times 1/5 times 4 square root of 2. Remember, square root of 2 to the 5th. Just write them all out, and it'll simplify to 4 square root of 2 minus 1/3 times 2 square root of 2. All right. So that's that part. And then plug in your 1. And that's just going to be 1/5 minus 1/3. All right. And then further simplifying, you're going to get 32. And this is going to be 2/15 square root of 2 plus 2 divided by 15ths. And if you want to pull out the 15, that would give you 6, or that we can pull out 2/15 actually. So I would give you 64 divided by 15. So we're just multiplying 32 times 2/15 and simplifying. And that would give you square root of 2 plus 1. And that's your final answer. Thank you. Have a nice day. Bye-bye.